detection and correction in computer networks. Have you ever wondered how computers manage to send data accurately even over noisy, unreliable networks? Today, we will explore how computers not only detect mistakes in data but also fix them automatically, making communication smooth and reliable. So, let's dive in and uncover the fascinating world of error handling in networks. The introduction to error detection and correction. When data is sent over a network, it can get corrupted or changed by noise or interference. So, the error detection means finding out if any error has occurred in the received data. And error correction means fixing those errors automatically without needing to resend the data. These both processes help make communication more reliable and accurate. Moving to the next, what is an error? An error happens when one or more bits of data change accidentally during transmission. For example, if the sender sends 1010, the receiver might get 1110 because one bit flipped from 0 to 1. This can happen due to many reasons like noise, interference, or weak signals in the network. The next is types of errors. There are different types of errors that can occur during transmission. First is single bit error. A single bit error is when only one bit changes, like 1001 becoming 1011. The next is burst error. The burst error happen when multiple bits change together. For example, 110010 becoming 5 times 1 and 0. The third one is multi-bit error. The multi-bit errors means several bits are changed but different random position. And the fourth one is random errors. The random errors occur unpredictably. And the last one is systematic errors. These errors can happen due to some hardware faults and follow a pattern. The error detection methods. To find errors, computers use different detection methods. The main ones are parity check, checksum, cyclic redundancy check or CRC, and Hamming code. Some methods only detect errors while others can detect and correct them. The first one is parity check. Parity check is a simple method where an extra bit is added to data to make the total number of ones either even or odd. For example, if the data is 1010, we add a parity bit 1 to make the total number of ones odd, resulting in 10101. This helps detect single bit errors, but it is not very powerful and can miss some errors. The second one is checksum. In checksum, the sender adds all parts of the data together and sends this sum called a checksum along with the data. For example, if the data blocks are 1010 and 1100, their sum might be 10110, which is sent with the data. The receiver adds the data parts again and compares the result with the checksum. If they don't match, it means an error occurred. This method is used in protocols like IP and TCP. The third one is cyclic redundancy check, that is CRC. CRC treats the data as a big number and divides it by a fixed number called a generator polynomial. The remainder from this division is sent along with the data. For example, dividing data 1101011011 by a polynomial might give a remainder of 100. The receiver performs the same division. If the remainder is not 0, it means the data has errors. CRC is very good at detecting burst errors and is widely used in Ethernet and Wi-Fi. Error detection methods. Detecting errors is important, but sometimes we also want to correct errors without asking the sender to resend data. One method is automatic repeat request or ARQ, where the receiver requests the sender to send the data if an error is detected. This is used in TCP. Another method is forward error correction or FEC, where extra bits are added so that the receiver can detect and fix errors automatically. Hamming code is a popular example of FEC. The Hamming code example are here. The Hamming code adds extra bits, that is parity bits, at specific positions like 1, 2, 4, and 8 in the data. These bits help the receiver find exactly where a single bit error occurred and correct it. For example, if the sender transmits 1001101 and one bit flips during transmission, the receiver can detect the error position and flip the bit back to fix it. This code is widely used in computer memory systems and communication to improve reliability. The conclusion. In conclusion, errors are common in data transmission but can be managed effectively. Error detection helps us find if error occurred and error correction helps fix them. Different methods serve different needs based on the level of accuracy and complexity required. Together, these techniques help build reliable and trustworthy communication networks. Thank you for watching.